portable LIDAR. It is based on atmospheric laser spectroscopy for remote sensing of chemical distribution in the environment of Moon. Life can be inferred by the presence of atmospheric biosignature gases produced by life that can accumulate to detectable levels in an exoplanet atmosphere. Detection will be made by remote sensing by sophisticated space telescopes. The vision for the path to assess the presence of life beyond Earth is being established. Celestial objects with exposed solid surfaces such as Mercury and the Moon were for many years thought to have no atmosphere. Their spectra were almost featureless with wide absorption lines that are characteristic of minerals. Since the spectra were thought to be dull, researchers paid them no attention for a long time. However, a big wake-up call arrived in 1985 when a thin atmosphere containing sodium was discovered as emission lines by ground-based observations. Researchers expected the sodium to have been released, for a number of reasons. The atoms are retained by gravity, but they are ionized by the strong UV light from the sun and continuously lost. To be maintained, the atoms have to be replenished. It is natural to think that the Moon should have an atmosphere if Mercury has one. In 1988, the lunar sodium atmosphere was finally discovered, and then the potassium atmosphere. Spectrum of the Moon taken with the 65 cm solar telescope at Okayama Astrophysical Observatory in December 1996. The arrows indicate weak emission lines of the sodium atmosphere. Spectroscopy. Imaging spectroscopy, the acquisition of spectra for every point in an image, is a powerful analytical method that enables remote material detection, identification, measurement, and monitoring for scientific discovery and application research. From mapping vegetation species on Earth to studying the composition of the intergalactic medium, spectrometers can be used to reveal physical, chemical, and biological properties and processes. The presence of water ice was detected through the analysis of shifts in the color of light after the crash, showing the absorption of electromagnetic wavelengths specific either to the water molecule H2O or the hydroxyl molecule O, a breakdown product of water after the explosion. Carbon dioxide, methane and other carbon-based molecules were also detected. Calculation of water-vapor mixing ratio in atmosphere. Water vapor and aerosols are two interesting atmospheric parameters that are accessible to remote measurement. The water-vapor mixing ratio, which is defined as the mass of water vapor divided by the mass of dry air in a given volume, is conserved in atmospheric processes that do not involve evaporation or condensation. Increased knowledge of water vapor concentration and motion can lead to a better understanding of cloud formation, convective storm development, and the hydrological cycle. These measurements will be demonstrated through Raman LIDAR, which can be used as a meteorological research tool that is unique in its ability to capture the spatial and temporal evolution of water vapor in the lower atmosphere. Schematic of LIDAR system. The technology of LIDAR. A. DPSS laser. B. Light collecting optics. C. Detector unit. D. Data acquisition system. DPSS laser. The LIDAR uses a single microchip YAG crystal pumped by diode lasers. The laser delivers second harmonic of North Dakota, YAG, which is 532 nm in wavelength. The laser employed was Laser Export, Russian-make system. The laser system was employed with an acoustic switching unit for generating variable interpulse period and laser output. The laser pulse energy can be settable between 2 and 20 μJ depending on the repetition rate. Usually the laser was set at 10 microjoules with a pulse repetition rate of 2500. Fine beam of polarized laser exits the laser unit. Light collecting optics. A classical Cosine telescope unit was employed as the light collecting optics unit. The reflecting optics diameter of telescope was 150 mm. The focal ratio was 9. The telescope was arranged over a sturdy structure with a provision to tilt and rotate. Detector. A high-gain photomultiplier tube, PMT, was employed as the detector unit for converting the photons to electrical signals. The PMT operation requires a high-voltage DC supply for biasing purpose. The gain of the PMT depends on the DC voltage regulation. Data acquisition system. Photon counter was employed in this LIDAR for generating the range-resolved photon count data from PMT signals. The photon counter used was a high-density and multi-layer PCB card. The photon counting system was used as an add-on card to a personal computer for generating the photon count profile. The card works on the principle of time of flight measurement. Calculation of water vapor mixing ratio in atmosphere. LIDAR techniques which is commonly used for water vapor measurement are dial and Raman. Raman principle is used by most of the ground-based experimental water vapor LIDARs, which has lower laser requirements and offers better reliability. Provide measurements of lower and middle tropospheric water vapor mixing ratios in aerosol scattering profiling. It is achieved with high temporal and spatial resolution. LIDAR utilizes a North Dakota YAG laser that operates to measure backscattered radiation at 355 nm and Raman scattered radiation from N2 molecules at 387 nm and water vapor molecules at 407 nm. It operates Licell transient recorders for data acquisition that can simultaneously obtain both analog AD and photon counting PC signals, thereby expanding the dynamic range of the detection system. Algorithm flow chart. Start. Read the data from LIDAR signal. Change the raw data into ASCII data. Relationship between original data of AD and PC is analyzed and the linear region is calculated. The unit of AD data is converted into photon counting rates and is used to correct the saturated PC data according to the relationship obtained by curve fitting. At last, the gluing signal is calculated by the weighted average method. The glue coefficients, slope and intercept, determined from the regression, are used to convert the AD signal into a PC signal by using the equation C equals M at plus B single quote. Process the data for range and noise correction. Thank you.